Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years underhood experience for me. So our topic at hand today is EVAP systems. We're going to talk about how they operate. We're going to talk about the components. We're going to talk about how to test them. And there's a couple different ways we want to approach this and go about it. So we're going to walk through the couple different things. So with that, let's first start with the components so we can get grounded on kind of what each thing is, kind of like our vocab lesson for the day. And then we'll go through how it operates. So EVAP components, the main components. There's sometimes other little straggler components that aren't listed here, but the main components that you're going to find in pretty much any EVAP system is going to be Purge Solenoid, which I'd like to think of that as like the front door. So that's going to be the one that lets things into the house, which would be the engine. So that's your front door there. Then we have the vent valve, which is like the back door, which lets stuff in and out. And then we also have the canister, which collects all of our vapors. We have our fuel tank pressure sensor, which is going to measure the pressures in the system. And then pumps and associated modules, especially most modern vehicles, will have some sort of a leak detection pump or something like that. So there's a multitude of different ones that are out there. So we'll talk through that as well. So here's a little diagram of a simplified diagram of a EVAP system. And the first one we'll talk about is the purge solenoid, right? So that's that one right up there. It's the one closest to the engine usually. And that is the one that allows the vapors into the engine. So the EVAP system, as we know, collects the evaporative fuel vapors off of the gasoline vapors, collects them to be further reburned after because it's an emission. So it is a pulse width modulated controlled solenoid usually. So that means we can open it and close it however much the computer needs it to, from usually like steps from like 10% to 100%. And it depends on how long it leaves the voltage on or the ground on, depending on how it's set up. It is also used for leak testing because we need to seal the system in order to test for leaks, and that is one way to do it. Now, this kind of came up last week. So if you were watching last week live, we did a little giveaway, and part of the giveaway was we had a little survey where you entered your email address. And what we did is we asked, well, what are some other topics that you'd be interested in hearing about or whatever? And one person mentioned that they had heard, okay, you're doing EVAP next week. Are you going to be talking about Honda? Because Honda has two vent valves, they said. And I did a little research into it this week. I'm like, oh, I've never really heard of that. So that's kind of interesting. So went in, and actually it ends up being purge valves it has. Now it calls one the purge solenoid, which is this one right here. And this one's more of a diverter valve. I don't remember exactly what they termed it, but it's more of like a diverter valve, which will divert between either side of the intake because it's a turbocharged vehicle. So if it's under boost, you don't want to be releasing the purge vapors into the boost side. You want to be releasing it into the vacuum side, the inlet side of the turbo. But when it's not under boost, you can be releasing it into the other side. And sometimes it goes into both. So we have the purge solenoid over here, and then we have that little diverter valve there. So it goes into one side of the intake there, and then it goes into another side down there. And that is mapped out here from Honda. So it just says go to the fuel tank, to the EVAP canister, to the purge valve, and it either goes through valve B to one point, which is ahead of the turbocharger, or valve A, which brings it to after the throttle body. So after the turbocharger, intercooler, and throttle body in there. It depends on what vacuum state the engine is. So that's something that I learned new. So great for suggesting that. Thank you for the viewer that suggested that we look into that, because that's a little interesting. All right, so that was the purge solenoid. Now let's talk about the back door, which is the vent solenoid. Now the vent solenoid allows fresh air in and out of the canister. That's the important part, the out as well. It is an electric solenoid. Usually it's just on, off, open, close. That's it. It's either sealed or it's not. Usually by default, it is open, because when I need to fill my gas tank, I need to be able to get the fresh air that's in the gas tank out of the system. It's essentially a sealed system once this is closed. So I need to have that open in order for it to get out. Now, it's also used for leak testing, for sealing off the back end of the system, and then it may also be part of the canister. There's many, especially, like I said, in the modern vehicles, the leak detection systems and things like that. Oftentimes, they are pieces contained within the canister or within the leak detection system. Now, as I said, you need to have an open vent line in order to get gas in the tank. So this would happen all the time at Subaru, and apparently it happened at Mazda. It happens a lot on other manufacturers, I've heard too. However, on Subaru and Mazda in particular, I don't know if the other brands have. I know some of the other brands, it was other things. But on Subaru, when we were working at the dealership, usually this symptom would present itself as the customer comes in, can't put gas in the car. I got a quarter tank of gas. I know it's not full. I try to go to the gas station. It pumps for a second and then shuts off. Pumps for a second, shuts off. Pump for a second, shuts off. And what's wrong with my car? So invariably, we would always find once that occurred, is there was some sort of a blockage in the vent. And 9 times out of 10, it was a spider web made by this little guy right there, called the golden orb weaver spider. And I guess they must be attracted to the EVAP vapors or something, because they like to build little webs and little nests in there. And it got so bad on Mazda 6 that they actually had to do a recall. 2014 there, 2010 to 2012 Mazda 6. On certain Mazda 6 vehicles, a certain type of spider may weave a web in the evaporative canister vent line, and this may cause a restriction in the line. If this occurs, the fuel tank pressure may become excessively negative, in other words, excessive vacuum. When the emission control system works to purge the vapors from the canister. So basically, it can't get fresh air in to displace the air that it's going into the engine, or the vapors that are going in the engine, creates a vacuum, could cause the fuel tank to collapse. As the canister is purged repeatedly during normal operation, the stress on the fuel tank may eventually result in a crack, potentially leading to fuel leakage and an increased risk of fire. Indeed. So it looks kind of like this. There's a vent, little portion there, and there it is over there again. So it kind of looks like a little cotton ball. You wouldn't really know. You'd think, oh, maybe it's like a little filter or something. Nope, spider web. So you could use a little screwdriver and go in there, or some people like to blow air through it, just blow it away from your face so you don't have a spider in your eye. But yeah, simple enough, but it's thick enough. It is almost like a cotton ball in consistency. So it is thick enough to not allow air through. So it clogs it basically. Once you remove the obstacle, everything's fine. It just goes back to being able to fill the tank and whatever. But that was kind of interesting, and that's just always a tip that I like to make when I'm talking about EVAP systems, is if your customer can't fill their fuel tank for one reason or another, it's probably that. Either a spider, or I've heard a lot of times Chevy trucks, maybe not so much now, but back, 2000s to 2016, 2010s, that era, maybe it's still true today, I'm not sure, but where they put the vent valve, which is above the spare tire, would basically just get all the dirt and the rocks and the crud that get in there, and it would just get mashed in there and turn into like a mud pie, basically, and not allow air in or out. So we get the same problem. And the ones that had plastic fuel tanks, which there were some of them, that would actually cause them to collapse. So not a good thing all around. You need to have that vent system open. All right, next part's the canister, and that's kind of the main star of the show. That's where it's going to collect all those vapors, and it can usually contains activated charcoal, which is going to absorb those vapors before they get reburned. It may contain electrical components as well, like I said before. This one doesn't. This one's just a couple of lines with some quick connects, and it's just a charcoal canister. But in this one, I think this one's off like a Ford Explorer, I think. That one has an integrated vent valve. You can see a connector right there, and you see how it kind of clips on, but it is not available separate. It's available only as a unit, so you'd have to buy them both together. So that's the canister. And then the last piece of the puzzle is going to be our fuel tank pressure sensor, which is going to reside on top of the fuel tank there. And that does exactly what it says it does. It measures fuel tank pressure. Outputs a voltage depending on pressure. It's going to go up or go down depending on whether the pressure is going in a positive or negative way. Usually it's a 3-wire sensor with voltage, signal, and ground. So usually it's a 5 volts or 12 volt reference, and then a signal goes back to the computer and ground for ground. Here's an example on a 2016 Tahoe, right? So you get the sensor signal, low reference, and 5 volt reference there. So it just tells you the pins. It says key on engine off. Voltage should be about 1.3 volts to 1.7 volts with no pressure or vacuum. Remove the gas cap to make sure of that. Replace the fuel cap as vacuum builds at the fuel tank. Voltage will increase. With pressure, voltage will decrease. And then there's also at the in a harness connector that's there too. There's another place you can go and test it. So it gives you an alternate place. There are also many leak detection devices on modern vehicles. Didn't used to be this way, but it is now. And that is because they're trying to keep these systems as sealed as possible. I know on my Subaru, which this is a picture of the one that fits my Subaru, it says it has a little tag on the back, and you may have seen one before on, I don't think it's just on Subarus, but they made a big deal out of it for sure. It says PZEV on them. So that stands for partial zero emissions vehicle. Now the zero part of the emissions, certainly not the tailpipe, it's this, it's the EVAP emissions. So their goal was to get it to zero EVAP emissions. So no EVAP emissions getting out of the vehicle. So the vent valve and everything. So it doesn't really allow for that. So it has this leak detection module in here, which I think they actually got from Toyota. But anyways, it's usually mounted in the passenger compartment in the back underneath the seat or in the trunk and the deck there. And it's all self-contained. It's got a pump. It's got a carbon canister. It's got the vent valve. Everything's kind of all in one place where it needs to be. All in one unit, which means you have to buy it all as one unit too. But here's the example off of mine, right? So leak detection pump and sensor are used as a pair to not only detect evaporative leaks, but also detect the size of the leak. The leak pump will draw a vacuum on the evaporative system. The pressure sensor will then monitor the system in the tank and look for any leaks. The drop in voltage will indicate a leak in the EVAP system. Leak detection pump is part of the vacuum pump module assembly, combining a vacuum pump with a drive motor, canister, vent valve, and a pressure sensor. ECN commands the vacuum pump to apply vacuum to the EVAP system during a self-test. Test either the canister valve or the pressure sensor. Go to EVAP system in the menu. None of the internal components can be serviced separately. If any fail, you need to replace the whole thing. And then there's what the pump says, the pinout right there. Vent valve control, 12 volts to leak detection pump ground, 12 volts to canister vent, and so on and so forth. And if you look at the Toyota Avalon, a 2016 Avalon, tells you the exact same thing because it's probably the exact same pump. Toyota owns a portion of Subaru, so that brings you there. Now, this is interesting. This is true for Toyotas, Subarus, and anybody else who uses this type of system. So it checks for EVAP leaks and canister pump module malfunctions. The monitor starts after 5 hours after the engine switch is turned off. At least 5 hours are required for the fuel to cool down to stabilize the EVAP pressure, thus making the EVAP system monitor more accurate. Now, as I said, it's 5 hours. If I'm a technician and I just made a repair, I'm not waiting 5 hours. So luckily, there is a way in the scan tool to force this on Subarus and Toyotas. Probably other vehicles too. But in that case, it also says if the coolant temperature is not less than 95 degrees 5 hours after the engine switch is turned off, it waits another 2 hours. If it's still not less than 95, 7 hours after it's done, and it starts 2.5 hours later than that. So it could take 9.5 hours before it runs this test, or maybe even longer if it's 100 degrees outside. So just be aware that some vehicles, that can happen. So you might need to go in there and force it using that automated test. Another module that might be used is the Chrysler eSIM. So that stands for EVAP System Integrity Module. So that is the newer version of that. They also had another one that was called the NVLD, which is the Natural Vacuum Leak Detection. They've used both in different ways. But basically the eSIM, that one that I just showed the picture of, is very similar to the NVLD. The design of the eSIM has been simplified so it does not require a solenoid. The eSIM mounts directly to the canister, eliminating the need for a mounting bracket. It is critical that the eSIM is mounted vertically. On vehicles where the canister is mounted at an angle, the eSIM requires an adapter to maintain the vertical position. When the eSIM is installed vertically, the electrical connector is going to be in the 3 o'clock position. It consists of a housing, a small weight, and a large weight that serve as check valves, a diaphragm, a switch, and a cover. There's one large weight and one small weight check valve in the eSIM assembly. A seal is attached at the end of each weighted check valve. The large weight check valve seals for pressure. The small weight check valve seals for vacuum. The weighted check valves are contained within the eSIM housing. And then, judging by whether or not it leaks, it will open or close those check valves. Depending on engine displacement, either one or two EVAP canisters may be used. BMW has a similar system to that. It's a DMTL, which stands for Diagnostic Module Tank Leakage. So that's on kind of the older ones. This is a 2010 335i. So there it is right there. It's got a little automated test that it'll go through. There's some theory and operation we can go through. There's some actuator tests we can do. The full tank leak test and the diagnosis and symptom tips are in there as well. So here's some theory and operation. I'm not going to read through this whole thing. It just says the DC motor leak detection pump ensures accurate fuel system leak detection. Leaks are as small as 0.5 millimeter. Pump contains an integral DC motor, which is activated by the DME. Then if we come down here, it could be a software error, may cause the mill to illuminate for EVAP system failures in vehicles equipped with manual transmissions that are driven under the following conditions. So just a couple tips there as well. Now, we'll see on the newer one that I'm going to pull up a little later, they actually use that, the NVLD, the natural vacuum leak detection, which takes 12 hours, and there's no way to force it, by the way. So now that we know the players in the game, let's see how the game is played. So this spiffy animation here. So we got our front door, which is our purge valve. We got our back door, which is our vent valve. And we got our fuel tank pressure sensor there, and the Mr. Computer controls it all. So the back door needs to be open by default so we can put gas in the tank. Front door is going to be closed by default, so we're not drawing vacuum on a system when the engine's running. Engine's not running right now anyways, but we're filling up the tank. As we fill up the tank, it generates vapors. Vapors go through the lines and displaces the fresh air that's in the canister and sends the fresh air out. Once that's done, we need to burn it. So engine warms up. We're going to leave the back door open because we need fresh air to come in and displace this vapor. It's going to open up the front door, though, which then allows vacuum to get into the system, which is going to pull outside air in. It's going to go through, and it's going to get reburned. Now, as the vehicle is still running and it is continuing to draw down a vacuum on the system, at some point, it's going to close the back door. So it can draw vacuum on the system, on a closed system. So it's going to be drawing vacuum in here now. And then you'll see the fuel tank pressure go to vacuum. Once it is in a vacuum state, it'll close the front door. So now I have a sealed system and it should hold a vacuum, theoretically. A timer will start in the computer, and it will measure how long it takes that vacuum to decay. If it doesn't decay, guess what? No leaks. If it does decay, however, then we know we do have a leak. So if we see it decay, depending on how long it takes to decay, the computer is then able to calculate the size of the leak, and that's how we get a code, depending on what it thinks the size is. And size does matter, especially when it comes to EVAP codes. Also, when it comes to EVAP codes, I want to make this point. I want to stress this point a little extra. Just because you see an EVAP code, don't make the mistake of assuming it's a leak, because it might not be. I've talked to plenty of people. I've seen stories about it. I've seen plenty of it happen out there where they say, oh, it's an EVAP problem. It must be a leak, because they didn't read through the whole description of the code. Yes, we do have leak codes, 440, 442, 456, 457. Very small leak, EVAP problem. Gas cap, 440 is more like a gross leak. But then we also have electrical problems. Purge control solenoid, stuck open, stuck closed. Vent control solenoid, pressure sensors, purge solenoids. All of these can have electrical codes associated with them as well. So it's going to be, if I have a leak code, I'm going to have to check certain stuff. If I have an electrical code, I'm going to have to check a different certain number of stuff. So we always need to be aware of what kind of code is it. Don't just look at the word EVAP and assume, oh, it must be a leak, because it's not. Not always. I'm sure oftentimes it is, because I'm sure leaks are probably more common than electrical. But usually if we look at top 10 lists and codes, by the way, it's usually at least 1 or 2 EVAP codes in there. They're still super common even to this day. So if I'm going to do leak testing, I would say, in my experience and my opinion, having a smoke machine Doesn't even have to be this one. Doesn't even have to be red. I really don't care. But having a smoke machine or an EVAP testing machine is going to be invaluable for finding a leak. At the dealership, we never had one. And you know how many EVAP leaks Subarus in the Northeast have? A ton, because they rust underneath. On the worst one was the fuel filler necks. So they had a plastic cover over those fuel filler necks, and sure enough, they didn't have a way to drain out all the mud and crud that would get in there from driving down the roads and with all the salt and everything on there. So it would just eat away at the tube, the filler neck, and then you'd get an EVAP leak. And if it got really bad, you get a fuel leak. This was double walled, so as soon as the outer wall went, you'd have an EVAP leak. So you'd have that problem all the time. And then there was metal fuel lines that ran through the frame and all. Wish I had one of these. I could not imagine how many hours this would have saved me. A smoke machine. So this is our smart smoke. This is the only one that's digital in the world, so it actually quantify the size of the leak, so you know whether or not you actually have a leak, where it's a problem. But it also allows the smoke in, so that I can see where the smoke comes out. For example, if it's a 455 gross leak, it's probably going to be a lot of smoke. It's going to be a big leak. 442 is a small leak, and that was from 99 and older spec, so 40 thousandths leak. A PO 456 is considered a very small leak of 20 thousandths. That's 2000 and newer vehicles had that spec. And then there's even newer vehicles, and Chryslers especially, that are down to 0.10. And I'm sure there's some, I bet you Subaru spec is 0.0 because it is a PZEV vehicle, partial zero emissions. So the zero part would lead me to believe they probably want zero. You can see right there, there's some smoke coming out. There's where it's leaking. There's where it's leaking. There's a leaky vent valve. Got to fix the vent valve first before we figure anything else out. But that could cause a leak code. That could cause an electrical code. That could cause both, I suppose. Here's one where they cross-threaded the sending unit. And they didn't realize it. It looked okay. They cross-threaded it and then didn't realize why they had an EVAP leak. And sure enough, it was just leaking out. And here's one. There's a canister right there. See the black canister with the bolt and the clips. And then this is an EVAP line off that canister, and it was leaking smoke. Right? Makes it a lot easier to find a leak when you just put smoke in, put a little pressure in the system. It's only half a PSI, but it's enough to get a leak out to cause the code. So those are invaluable. If you're trying to do EVAP diagnosis and it's kicking your butt and you don't have some sort of a smoke machine, EVAP testing machine, whatever, something to put smoke into it, I would look into that. Because I could not tell you, like I said, how many hours that would have saved me over my career. If only we had one. And we kept asking for one too. Anyways, if I'm electrical testing, I need to know other stuff. I need to know wiring diagrams. I need to know how does it work. I need to know what the pinouts are. I need to know what the wires are. Usually they're fairly simple. They're not more than a couple, 3 wires, unless it's like one of those leak detection things, then maybe it's like 8 or 10, but not all the wires do everything. So for this is a, EVAP Purge Solenoid on a Camry, and it's 12-volt power source and ground. It's on off. Simple. At least I think it says on off. I don't know if it says whether or not it's ground. Yeah, modulate purge line vacuum. Yeah, so it's modulated, pulse width modulated. So let's take a live look into the tool. See some stuff that we can see. I'm gonna start with that Camry, I think. Yeah. I'm gonna start with Honda. So Honda's got those 2 things. I'm gonna go to the scanner, and we'll see. I think there's a couple tests that we can do here. Engine. Sure. No, it's not a functional test. Now I gotta wait 10 seconds. Special function. Fuel pump on and off, but that's not going to help us any. Special function. 5 seconds for that. Okay, so looks like in this case, it doesn't need it. Doesn't need anything. So let's go over to shop key quick. And look at that. Number one code is an EVAP code. Another one down there. So that's a leak, small leak. And this one is vent valve solenoid circuit malfunction. So that is an electrical code. So that's interesting. They don't have any diagnostics for that. Interesting. 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 Let's go back here. Honda doesn't have anything for that. But I'm going to go look at, was it vent valve? Vent valve. All right. So we can get some, let's see, how about operation? All right. This is where they talk about the two pieces too. Non-return valve V and non-return valve A. And then wiring diagrams, right? So we're going to go in there. And we're going to find it. Tank unit. There's the EVAP leak check module right there under right rear floor. So there's the motor, there's the sensor, there's another controller right there. So a lot of stuff you're going to do right from there with vent valve. So that's pretty pricey. That's got to be pretty pricey then. Let's see. Because I think it's part of the, yeah, it doesn't even list it separate. So it's part of the canister. Let's look up the canister on this thing. Yeah, it's $400 for the canister. So there you go. Even got a picture. Number one. There it is right there. Yeah, it's got vent valve in it. And a pressure sensor. Well, there you go. Also, we can look up information in the guided component tests. That'll give us a good amount of information. So let's see. EVAP. Leak detection module. So that's got 8 pins, right? 5.0 reference and such. Vent control. DC voltage test for that. Looking for 12 volts or ground. All right. So that's that. Let's go look in the... and that's going to have... not on this simulator. So I can go in here on an actuator test, though, and activate the vacuum pump. Activate the EVAP purge. Activate the vent. Vacuum switching valve. All right, so we have all of that in there for functional tests. Then if I go into my shop key, let's see, number 4 code is EVAP incorrect purge flow. And then number 7 is a gross leak. So incorrect purge flow could be a lot of things. You're going to want your wiring diagrams. You want to want your R&R procedures as well. Just going to give you a few hints there. When I'm testing, it's going to walk you through what you need to do. So it gives you detail codes as well. Incorrect purge flow, actuator stuck on, actuator stuck off, low or sufficient flow. It's going to depend on which one of those subcodes it is as to what the actual problem is. So once again, you need to look at that code and read that code to make sure what you got going on. And then as far as guided component tests, there's going to be a few in here. EVAP system. So leak detection pump. It's going to tell you all about it. Once again, 8 pins. Purge solenoid. This one even has a location image. So it's right there. Right top there. Signature tests. Turn solenoid on and off. Little tech tip in here. For the purge solenoid, if no short to ground or open circuit exists, remove with hoses and blow through the ports. If it's normally closed, air should not pass through it. When checked on a running engine, vacuum shouldn't be present at the port, not connected to manifold vacuum source with the connector unplugged. Using small jumper leads, supply battery voltage to the terminals. Battery power air should pass through the ports. If okay, connect the hoses. So that's basically an on or off. Turn it on, turn it off. All right. And then we have a Ford. So that's going to have a couple things in there. see. So on this one, they have a gross leak test and a small leak test. And it also has a cold soak time bypass. This one must have one of those pumps again, where you have to wait for a time before you do it. Output controls too, you'd go into to get your purge valve percentages and your vent valves, that sort of thing. And then if we go into SureTrack, drop key, let's see, EVAP flow during a non-purge condition, EVAP emission system small leak detected. So if we go in there, it's going to tell us how it's like could be blockages or purge valve stuck open or something like that. And then if we go here, got a component tests and EVAPs over here. Vapor blocking valve. So this has what they call a vapor blocking valve. So it's able to block off the tank from the rest of the system if it needs to. Normally open valve, the PCM closes the blocking valve to isolate the fuel tank from the rest of the EVAP system. The EVAP vapor blocking valve will automatically open and relieve excess pressure or vacuum in the fuel tank. That's just simple 2 pins, on or off. Purge Solenoid, that one has a location image as well. It's right on top of the little snorkel there. Signature test on that one. That one's pulse width modulated, so you can see how it kind of goes up and down like that. And last one's going to be a beamer. Oops. I don't remember if this one had a test or not. Looks like not. Probably has an actuator test though. Tank ventilation solenoid valve right there. So we got a functional test for it. And then in guided component tests, EVAP system. There's an NVLD unit, like I said. So they used to use that DMTL that we talked about. Natural vacuum leak detection. Unlike conventional leak detection system, the NVLD system operates off a natural vacuum. Natural vacuum occurs in the sealed fuel system after it starts to cool and the pressure drops. After a predetermined amount of time and the temperature is dropped enough, vacuum will build up and close the vacuum switch. Vacuum switch is monitored by the NVLD diagnostic module. If the pressure in the fuel system remains high and the temperature is dropped below a predetermined value, NVLD diagnostic module will report back to the ECM that a leak is present. Or if the vacuum switch closes and it opens again after a predetermined amount of time, a fault will be set for a leak as well. This test is a long test, approximately 12 hours, and the vehicle must be in a rest state. So basically, you got to wait for the vapors to be in there and to cool off and to condense and to create a vacuum. So it could take 12 hours. Sounds like not fun. So there's a picture of the natural vacuum leak detection pump. And the engine may use either NVLD or the diagnostic module tank leakage, but not both. So one or the other. So know what you're dealing with when you get into that. Lots of interesting stuff out there. All these manufacturers have their little idiosyncrasies, but I think what it really boils down to is what I said earlier. So if you get an EVAP code, because they're still very common, to help you with diagnosing it, first you need to decide, is it a leak code or is it an electrical problem code? And the definition of the code will tell you that, or at least it should tell you that. You might have to look into manufacturer's information for a little bit, but the majority of it will be there. And then if it is a leak check test, you would definitely be a lot better off if you had a smoke machine or an EVAP tester or something of that nature. I know I would have been. And then if it is electrical, you're going to need wiring diagrams and pinouts but usually it's simple enough, 12 volts, 5 volts ground. It's pretty much all we're looking for. You can probably do it with a meter, or you can do it with guided component test, which tells you all that information in there anyway. That is my story on EVAP. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.